So thanks for joining us today on Leadership Log, which is a podcast for the Air Force Lifecycle Management Center community on topics of interest. And the topic of interest today is advanced manufacturing. And so we've got two experts from the Rapid Sustainment Office to explain to us today what's the newest, what's the latest and greatest in the world of advanced manufacturing. So we'll start. Zach, if you could just introduce yourself and give us a little of your background.
Yes, thank you very much. Good morning. My name is Zach Miller. I'm the Chief of the Advanced Manufacturing Program Office here at the Rapid Sustainment Office, PEO. And a little bit of my background, I was active duty acquisition program manager in the Air Force, and I've got a pretty broad experience behind me. I work electronic systems, missile defense systems, space acquisition, a lot of special programs working in the vault. And my last job before coming to the RSO was in the anti-tamper program office.
Okay. And Beth?
All right, good morning. I'm Beth. I'm the chief for the Propulsion Integration Office in LP. My office does a lot of cross-cutting programs for the propulsion enterprise. Right now, we're really focused on innovative programs such as advanced manufacturing. My background before this position, I was in AFSC working logistics and requirements, and the majority of my career has been spent in propulsion, about 17 of 20 years.
All right, so that was my mistake. You both not from the Rapid Sustainment Office. Zach, you're from the Rapid Sustainment Office, and Beth, you are from our Propulsion Directorate. That's correct, right?
Yes, that's correct.
Okay, all right, good. But we still are here to talk about additive manufacturing. So let's, or advanced manufacturing. So let's talk about that. Could you give us kind of a rundown? What is advanced manufacturing and what are the benefits of it?
Sure, yeah, I'll start off. Advanced manufacturing is the use of innovative technologies to improve products and repairs out in the field organically. Advanced manufacturing identifies new and emerging technologies to improve readiness and drive down sustainment costs, especially for those parts that have obsolescence issues and are really hard to identify source of supply. Advanced manufacturing includes 3D printing, directed energy deposition, and laser clad welding for repair services. The Advanced Manufacturing Program Office was established in October of last year, October of 2020. And the main purpose of the Advanced Manufacturing Program Office was to counteract those obsolescence issues, improve mission readiness, and also drive down sustainment costs. I think a lot of us have seen some of the statistics that overall weapon system acquisition costs come in the sustainment phase. So that's one of our main drivers.
Okay. And what are some of the challenges that you've found so far with advanced manufacturing?
Yeah, so some of the challenges that we found is it's just such a new technology, and changing the mindset within some of the program offices to consider and adapt advanced manufacturing into their workflow and processes. There is a lot of capability and viability within additive manufacturing to be able to counteract those parts obsolescence issues. And a lot of times what I've heard from the field is it's 300, 400, 500 days before a part is available to be used to get on the whatever aircraft that it's required for.
Mm-hmm. And so that's kind of the significance of the two of you being here today, is the fact that you representing the RSO, kind of finding out, discovering these new ways of technology that they could improve in specifically in the sustainment enterprise. And ma'am, you're here on behalf of the program office to see about ways that we can actually put that into scale, or to scale it across the enterprise. Is that correct?
Yeah.
Okay. All right. So what is as far as the Air Force goes, what strategic advantage does advanced manufacturing give us over any adversary?
So I think what it brings to us is the ability to improve readiness. So like Zach mentioned, you know, in propulsion and like other offices, many of our parts take, you know, 18 to 24 months to deliver. And that's obviously, you know, that's not good enough. So advanced manufacturing, you know, allows us to either manufacture the parts a lot quicker or repair them a lot quicker. It also allows us, you know, to save parts that we were traditionally throwing away because they were beyond their life. So now with these new technologies in the repair side, we can save a lot more parts, which reduces cost. And that allows the Air Force to spend that money that we would have previously spent on buying new parts on other programs or other efforts.
Okay. All right. And so how did this partnership between the RSO and LP begin? LP being the Propulsion Directorate.
So it began shortly after the RSO stood up back in April of 2019. GE Additive went and pitched an idea to Dr. Roper, and they took an F-110 sump cover that they had printed for their own use, and they had pitched this capability to Dr. Roper, and you know, he was a big fan, and they touted that this part, you know, traditionally took about 18 months to manufacture, and they could print it, you know, within a couple of months. So that's huge. So the RSO, being the program office for advanced manufacturing, had the lead for that effort. And then since it was a propulsion part, LP was also involved, and we started meeting with GE Additive and kind of mapping out, you know, how we would take this part, get it qualified, and get it flying. And from those early discussions, the Pacer Edge program was born. Okay. Working together ever since.
So tell us a little more about the Pacer Edge program.
Yeah, so the Pacer Edge program is a three-phased program that we developed back in 2019. So with the objective of taking this great capability and going faster. So the Air Force has been working in additive manufacturing for quite some time, but by partnering with GE Additive, we recognize, since they are the industry leader in additive, they've got parts that have been FAA certified and are flying on commercial jets, that by partnering with them and getting their expertise, leveraging their billion-dollar investment, we could certainly go faster. So it's a collaboration, like I said, between GE Additive, DLA, RSO, LP, and AFSC, with the objective being to stand up an organic capability at the REACT lab to print flight-worthy hardware that can go on propulsion systems, aircraft, support equipment. To date, we have executed all three phases. We're certainly not done. There's still a lot more to do. But we got the first, our first part, which was the F-110 sump cover, approved through the airworthiness and CCB earlier this year, and it is flying on F-16 aircraft. And then for phase two, we've purchased material data, and we have parts that are being redesigned for additive. And then for phase three, we purchased two concept laser printers that will be delivered at the REACT lab next month, and more material data. So we are underway.
And where is the REACT lab?
At Tinker Air Force Base.
All right. So these parts would be produced on an Air Force base. And would they be produced on like an as needed basis? Is that how it goes, or?
Yes.
Okay. All right. So what what do you think has been the biggest impact on the Air Force so far? And do you have anything that you could show us?
Yeah, so we've had some successes. We have some parts here to show you. So this is the F-110 part I was talking about. Obviously, this is half of it.
Okay.
So the whole part, obviously, you know, there's another half that's actually flying on the aircraft. So this was the F-110 part that we got approved and qualified. So this part was designed, printed, and qualified in less than 12 months during the height of COVID, which is pretty awesome. So these parts have been installed on 4 different aircraft and are flying. So far, the performance is great on these. So this was phase 1A, and it's complete. And then have a few parts from phase 2. So this is a J85 part that is being redesigned for additive and will be printed at the REACT lab. And then these are 2 TF33 parts that have been redesigned for additive. And for those of you familiar with that engine, you know, very, very old engine, lots of obsolescence issues. Also a non-GE engine. So another benefit from partnering with GE Additive is that we can redesign and print parts that are OEM agnostic.
Okay. All right. That's cool. And the TF33, that's the one that's the jet that's on the B-52, correct?
Yes, sir.
Okay. All right. Good.
So that's one piece with the sump cover part. That was originally, I think, 14 different parts. And through additive manufacturing, we got that down to three parts that were then additively manufactured together. So it reduces the complexity, reduces testing time, and can also reduce some of the weight of the original OEM part as well. So those are some of the other benefits.
Yeah, so you can have like it can make complex shapes. It can, you know, take out excess material that otherwise would be difficult to machine out. Is that correct? Or
Yes, that's correct.
Okay. All right. So talking about this technology then, what do you think the future of additive or advanced manufacturing is, and where do you see it going, like in, say, the next 5 years?
Yeah, that's a great question. As you have probably heard, industry and other entities outside of the DoD have been using advanced manufacturing for years. And we're pulling in some of those best practices that we're learning from our industry partners into the DoD and the Air Force specifically for our application. We've made a lot of progress over the last few years, and I just think really the sky's the limit moving forward with advanced manufacturing, whether it's additive 3D printed parts or also repair. With repair, it's using a technology that can take an original part that has a defect or something is wrong with it, and it can build it up to the original standards of that part. So return on investment is very high on the repair side of the house. We can go out and repair something for $4,000 or $5,000 the cost of materials and doing that organically, versus ordering a brand new part and having to wait 12 to 18 months for that part to come in.
Yeah. So let's talk about the savings here. I mean, in terms of time, okay. You know, if a jet breaks, all right, and it's on the ground, it's costing us money every day that thing's not flying, right? And so in terms of mission accomplishment, we need to get the parts quicker, all right? If we can get the parts cheaper, and if we can get them even better, then there's advantages across the board. So, I mean, is that all of the advantages you think, or the savings that potentially we're looking at, or are there other savings in there?
I think also, and this one might be a little bit intangible, but with these technologies comes like the digital thread that goes throughout these parts. And I think that's going to be tremendous, because as we continue to, manage these older aircraft and engines, having that digital baseline and all the digital data that comes with it will allow us to be more responsive in the future, and then also be able to better predict whenever, parts aren't performing like they should be, and then be able to, let the maintenance folks know, like, hey, this, part is beginning to fail,
Right.
you need to order one. So that way that part's waiting, whenever that component comes in. So I think that piece of it is really exciting. And, when I think of advanced manufacturing and where we're going to be in 5 years, like Zach said, we've already accomplished so much, but there's still a lot to do. We have thousands of parts to go after. So I see us having this very, very broad catalog of parts and this digital marketplace where the user can go in and input their need. And then in that digital marketplace, it will show their options. Like this one can be printed, there's this advanced repair that's available. And then they can track that part throughout the process. So I think that's what's exciting.
Right. So right now the parts will be printed at Tinker. Do you see a time that maybe that capability would go into the field? So I mean, I guess obviously that's a place where most of those aircraft come back for depot maintenance, which is probably the most extensive maintenance that they get. So it makes sense to have it there. But do you think that there's a time when potentially this would go out into the field, and it would be something that even maybe units in the future would deploy with this capability and be able to print parts in like a bare base scenario?
Yeah, that's the overall objective of the Advanced Manufacturing Program Office, is to get the capability spread across the field, not just CONUS, but also possibly at deployed locations, so that we are able to do additive repair or parts replacement on demand as the warfighter needs it at the point of need.
Yeah.
So that's definitely one of the objectives we're going after. A lot of work needs to be done with the machines that we have right now. We're working on getting the different 3D printers qualified, and also our repair technologies. Along with that also comes the different material makeup of the parts and the repairs. So a lot of our efforts right now are focused on the material qualification and the machine qualification, and then making sure that the operators are trained up properly and certified to use those machines.
Yeah.
As we look forward, our plan organically is to have capability at Tinker, at Robbins, and at Hill Air Force Base, and then also at 2 other Air Force advanced manufacturing centers of excellence. And we're working with the MatchComs right now to identify which are the most appropriate places for those 2 other centers to be able to do repair and part production.
For propulsion systems, just the nature of them, I don't think a lot of in the field, printing or repair capability, but having that network established and making sure that there's always capacity somewhere, I think will definitely give us a lot more options than we have right now.
Yeah. So where do you see this collaboration between the 2 organizations going in the future, between the RSO and the Propulsion Directorate?
I mean, it's already been so much fun, like working together. We both have very small teams, but they're making some very big things happen. So I think we're going to keep collaborating and helping each other, build out and achieve, the goals that we have, and just promote this capability, and just try to help folks.
Yeah. Well, and you know, you can find the greatest technology in the world, but if you're not actually putting it into use in the programs in the field, then it's really kind of all for naught, you know? So, I mean, this collaboration between the two organizations is vital, I would think.
Yeah, absolutely. Outside of the Pacer Edge parts, we've already identified with the propulsion program office 9 other candidate parts that we're working towards. We're going to be ready to do fit check with those here in the next quarter. And right now we're really at the early stages of identifying what that process is, working with the different program offices, and the great strategic partnership that AM program office has with Beth and her team in propulsion is really going to set the baseline on how this works for future program offices.
Mm-hmm.
And right now, you know, our team works very well collaboratively. In addition to just the AM program office and propulsion, our offices are both also really tied into what's going on across the other services. There's a joint additive manufacturing working group that meets a couple of times a month. So we're collaborating directly with the other services on their capabilities. My chief engineer has gone out and seen the capability that exists across the different services for parts, for airworthiness, for the materials that we're going after. And as Beth talked about earlier, the key thing to make this all come together is a digital marketplace that will house all of the engineering documentation and technical information that is going to be required to identify if that part already exists and the technical data package is ready to go, so we can just hit print. And when that doesn't exist, we also have a process to introduce new candidate parts for the warfighters in the field. So I'm really excited about it. And I see this really just improving readiness overall for the warfighters and reducing costs, especially when we look across the next 5 years or so.
Yeah, just to add on what Zach said, you know, so something else I think we've done a really good job of is kind of looked out into the future. So on Pacer Edge, you know, recognizing that, you know, across the DoD, there's only so much money to go around. So on Pacer Edge, we were fortunate to work an agreement with GE Additive so that the material data that we purchased could be shared, you know, with the Army and the Navy and vice versa. So that way our investments can go further, and it forces us to continue to collaborate and share, which I think is important because, you know, the Army and the Navy are both going after some really cool things as well. And if we can tap into their capacity and their capabilities and vice versa, then we don't have to, you know, spend the same money to get the same capabilities.
Yeah, that makes perfect sense. So speaking of that, if people watch this episode and they're interested in learning more about this, how do they reach you guys? How can they contact you?
Yeah, so for the RSO, we have a website out there that folks can go to, and within the RSO website, there's a filter into the Advanced Manufacturing Program Office, and that will give folks the opportunity to reach out to us. This happens pretty frequently, almost on a weekly basis, where a different program office is engaging with my team on different parts that particular office is having issues with from a source of supply. So that's probably the best way to reach out to the Advanced Manufacturing Program Office.
Okay.
For LPZ, you can find us in the global if you just want to send a note to the LPZ workflow. If you have any questions or want to learn more about what we're doing, happy to get with you.
All right. Well, thanks very much for your time today, both of you. I think this is a really exciting story. It's very interesting, and look forward to hearing more about it in the future.
Thank you.
Thank you very much.